So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's a reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. Yellowstone's alert level is currently green, but don't get too comfortable. This supervolcano is still alive, and it could erupt at any time. New data shows the caldera is breathing, with the ground slowly rising and falling as things move deep underground. If Yellowstone actually blew today, it would be a huge disaster. A 10-foot layer of ash would bury everything as far as 1,000 miles away, and over 90,000 people would lose their lives almost instantly. Now, the problem is there's some strange activity going on there lately, like the rare Geyser erupting all of a sudden. This is the biggest acidic geyser in the world that measures about 60 feet across. Think of it as a hot spring that shoots up acid. It's also scorching hot, with temperatures that can get over 200 degrees Fahrenheit. The Geyser was really active back in the 70s, and it used to erupt every 40 to 80 minutes. But it stayed quiet for the last 6 years until it erupted again in February 2026. The water shot 30 feet high and the eruption lasted about 3 minutes. It was quite a show, but people were worried. I mean, is this a sign the volcano is finally waking up? Well, probably not. Geysers turn on and off all the time. That's just typical Yellowstone behavior. But Aquinas isn't the only hot spring out there that's been acting a little weird lately. So, Yellowstone was the first national park in America, and it sits right on top of an active supervolcano. That's why there are over 500 active geysers over there. Basically, they're hot springs that get heated up underground and shoot water and steam into the air every so often. These geysers are shaped like a long tube or a hole that goes deep into the ground and fills up with water. Since the water at the very bottom is so close to the magma, or molten rock, it starts to boil. That pressure forces the water up and out in an eruption. Then the water slowly drains back down, and the process starts all over again. Having all these geysers around means the park is basically covered in steam, so it has this really mysterious, misty feel to it. And now it just got even cooler. The ground is literally moving. Lately, everyone's been focused right here, on the Norris Geyser Basin. This spot is home to the Steamboat Geyser, the tallest active geyser in the world. And since 2025, scientists have noted something weird here. The land, which used to be flat, now has a bulge in it. Yep, the ground has pushed up by about an inch along the northern rim of the Yellowstone caldera. But we don't have to worry about Yellowstone finally erupting and destroying the planet. I mean, the situation is pretty scary, sure, but it's not a direct sign that an eruption is on the way. To be fair, this is not even a new phenomenon. Between 1996 and 2004, the land did the exact same thing. The area just south of the Norris Geyser Basin rose by almost 5 inches. This happened because a huge pool of magma, about 9 miles deep, was pushing up from underground. It felt like Yellowstone was ready to erupt at any time. Everyone was terrified, thinking it was the end of the world. But nothing happened. Then, in late 2013, the ground started rising again, at a rate of about 6 inches a year. And that was faster than ever before. Everyone got super nervous all over again. But just like last time, nothing big happened. The event lasted until 2014 and ended with an earthquake with a magnitude 4.9. That was actually the largest one in the area since the 70s, but it didn't trigger a massive eruption. In fact, the last time Yellowstone actually erupted was about 70,000 years ago, and it was not even a huge blast. Now, the area where this happens is known as the Norris Uplift Anomaly, and scientists are getting pretty used to its strange behavior. They say that when magma moves into the Earth's crust, it cools down and releases trapped gases. As that gas escapes, the pressure drops and the ground sinks back down. But just when we thought the area was finally quiet, nah. Back in July 2025, scientists checked the data and confirmed it. The land was rising again. The whole process looked very similar to the one back in the 90s. This might also explain the sudden rise in the number of earthquakes in 2025. I mean, the year was actually pretty quiet overall, with only about 1,100 earthquakes. That's pretty low, considering that at least 1,500 happen in a normal year. But the number of earthquakes suddenly went up at the end of 2025, and most of them happened right near the anomaly. So scientists were pretty sure the two things are connected. According to the estimates, it looked like the ground was going to keep rising for a while. But they also said we don't need to worry about an eruption. The changes we've seen so far are actually pretty small. They're nothing compared to the warning signs we'd get if Yellowstone was really about to blow up. Plus, we have way better tools now than we did in the 90s to track all these ups and downs. But one thing we know about volcanoes is that they are unpredictable. So against all the projections, something strange just happened. The ground stopped rising. Exactly. Recent measurements show the upward movement that had been happening since July 2025 has paused. So, whatever was going on under the Norris Geyser Basin just ceased, for now at least. Then there's something else that shows the caldera is back to normal. In February 2026, there were 74 earthquakes out there, which might sound like a lot, but for Yellowstone, it's not. That's a pretty standard number, because about half of the earthquakes in the park normally happen in swarms. I mean, groups of quakes that hit the same spot around the same time. And these swarms can trigger 10 tiny quakes in an hour, for example. To give you an idea, the year with the most earthquakes was 2017. That year, we were seeing something like 285 earthquakes a month. And even then, that wasn't considered dangerous activity. So, if February only had 74 quakes, we can consider it supernormal. Okay, so the caldera looks like it's quiet again. Does that mean we're safe and Yellowstone won't blow up? Not really. Then again, volcanoes are totally unpredictable. Yes, I'm repeating myself. But even with all the high-tech tools we have today, we don't exactly know how they will behave. So, technically, it can erupt at any time. Now, some people might think that Yellowstone is overdue, but that's not really how it works. If you look at the map, there's an average of about 725,000 years between its big eruptions. Based on the last time it had a big blast, we've technically got another 100,000 years left. But honestly, that average doesn't mean much, because volcanoes don't follow a schedule. Now, if Yellowstone did blow, it would be a total disaster. Some say it would be way more powerful than anything humans have ever seen. Computer models show it would blast tons of ash and toxic gas into the sky, making it almost impossible to breathe. That ash could even reach Europe in 3 to 4 days. The magma would completely wipe out the region, swallowing up forests, rivers, mountains, and anything else in its path. But scientists say the chances of an eruption are super tiny. And there's more. One of the magma chambers under Yellowstone is only about 5 to 15% liquid. The rest is basically solid rock. Hot rock, but still. It's not even clear if there's enough runny magma down there to cause an eruption in the first place. Anyway, that doesn't mean we should completely relax. Experts are still keeping an eye on the North Geyser Basin to see if anything changes in the coming months. Actually, the whole volcano is constantly monitored, and this situation is just another reminder that Yellowstone is still very much alive.
It's official. We now know the exact location and timing of the Yellowstone supervolcano's next eruption, and it's called a supervolcano for a reason. It will be thousands of times more powerful than a typical volcanic eruption. When this happens, the planet will face massive disasters. Earthquakes, tons of magma flows, ash and clouds that will block out the sun. The sky will be gray for a long time. We will have a shortage of food because of the lack of sunlight. Planes won't be able to fly. Some species of animals and trees may disappear. One disaster will follow another, like falling dominoes, one by one. Terrible times await Earth, and okay, stop. It's clear we got it. But when will all this happen? Don't worry, you won't be left without an answer. When ordinary volcanoes erupt, it's always a disaster, but only for those places that are located near the epicenter. Multiply the damage from an ordinary volcano by thousands and you'll get a supervolcano eruption. Yellowstone is one of the largest volcanic systems in the world. It's erupted 3 times in the last 2.1 million years. The last time was 640,000 years ago. The ash covered an area comparable to about half of the United States. Fortunately, there were no people there, but nature got hurt. A similar eruption of a similar supervolcano occurred about 74,000 years ago. It was the Toba supervolcano in Indonesia that caused an apocalypse the human race barely managed to survive. According to some theories, only a few thousand people stayed alive at the time during the volcanic winter, but it's not confirmed. Since Yellowstone is a volcanic system located in a vast national park, it was important for scientists to find out exactly where the first spark would come from. They found out that Yellowstone's magma doesn't accumulate in one place, but hides in several separate underground reservoirs. The reservoir in the northeast of Yellowstone, next to a beautiful place called Sour Creek Dome, is the riskiest. Here, the red-hot magma comes into contact with the hot rocks of the mantle, which are located deep in the ground. Their high temperature keeps the magma in a liquid state. Imagine that you put a pot of hot milk on the stove. Nothing cools down, but only gets hotter, so the milk may soon begin to rise and flow out of the pan. The same thing is happening with the magma under Sour Creek Dome. Magma doesn't cool down there, and at some point it may start to come out. It'll be like a broken pipe from which a fountain of boiling water gushes. But how did scientists find out? The magma reservoirs are located at a depth of about 6 miles, and this whole area is incredibly hot. They used a special method called magnetotellurics. So, Earth's rotating core creates a magnetic field that surrounds our planet. Magma flows around the core, and it contains many magnetic minerals that also create magnetic fields. Scientists use special instruments that sense those fields emanating from the magma, like a metal detector senses lost jewelry on the beach. Using magnetotellurics, they scanned Yellowstone and discovered 4 large magma reservoirs. 3 of them emitted powerful electromagnetic waves, and in the 4th, which is in the northeast, they recorded a much stronger signal from the magnetic field. This is where the eruption is supposed to occur. But fortunately, it won't happen soon. Perhaps in tens of thousands of years, perhaps in hundreds. Phew, you can relax. No volcanic apocalypse is coming soon. But how do scientists know when this magma will start to erupt? Magma doesn't have a timer, and the volcano doesn't wake up with an alarm clock. So, magma flows inside the pores of solid rock. It resembles a dishwashing sponge with lots of small holes through which water passes. Magma penetrates these pores and fills them. For magma to start erupting outward, it must fill at least 40% of these pores. About 20% of them are filled now. But these hot rocks continue to heat the magma and keep it liquid, so it can flow between the pores. At some point, it will connect with other pools of the liquid magma and become a large stream that will rise to the top. How can we prevent this from happening? It seems that the solution here is to cool the balsam rocks, but it's impossible to do so. They are several miles deep, they are incandescent, and there are too many of them. And in any case, trying to cool a part of the Earth's core sounds like a very bad idea. All we can do is accept that nature has its own plans. If the eruption occurs in tens or hundreds of thousands of years, then perhaps humanity will find a way to solve this problem. If not, then we should prepare for the consequences. A huge global catastrophe starts with a massive, large-scale explosion. The erupting magma produces a gigantic amount of ash. A powerful burst of energy collapses the Earth's crust over the magma reservoir. This leads to the formation of a giant caldera. You've probably seen a huge crater in a volcano. So, this is the caldera. The natural disaster is so loud it deafens everyone who's nearby. The blast wave rises ash and pumice stone at a speed exceeding the speed of sound. Volcanic materials reach incredibly high altitudes in minutes. Then, this pillar of ash spreads and plunges a huge territory into darkness. The incandescent particles in the lower part fall under their own weight and heat the air around them. It's almost impossible to breathe. The red-hot pieces of pumice stone and ash set fire to the surroundings. All this hot mass turns into pyroclastic flows that destroy and burn everything in their path. Forests, houses, roads, everything turns into coal. No planes can fly there. Tiny particles can penetrate engines. Besides, it's impossible to see through such a dark gray, hot cloud. It's also dangerous to drive cars. Volcanic particles can burn tires. Luckily, thanks to seismic technologies, people have learned in advance about the eruption, so everybody has evacuated. The column of ash that has reached the edge of space continues to expand in different directions. The wind helps the volcanic dust expand. A giant umbrella-like cloud appears over the territory of Yellowstone. It's getting wider and wider and plunges a huge area into hot darkness. During the first 24 hours, ash falls on most of the United States and parts of Canada. It knocks out power lines, pollutes bodies of water, and destroys crops. Then, the rains begin. The water mixes with the ash and falls to the ground in the form of gray mud. And don't forget, it's also poisonous. The ash contains mercury, arsenic, and lead in large quantities. Such toxic masses poison rivers, lakes, land, and air. All this time, the volcano continues to erupt. The outbursts of magma, ash, and pumice can last for several weeks or even a month. And this is just the beginning. The ash soon begins to settle, but the sulfur dioxide released during the eruption spreads all over the atmosphere. This gas mixes with the atmospheric water vapor and forms an aerosol consisting of small particles. All this covers the planet like a veil. This cap makes it difficult for the sun's rays to pass through, which means it lowers the temperature of the Earth's surface. These events cause a sharp cooling of several degrees in the world. Farmers lose a huge amount of their crops. Food prices rise and economies collapse. There might be a famine all over the planet. Human civilization can plunge into chaos. In a few years, the temperature will start rising, but it will take at least a couple of decades to return to previous standards. What will become of humanity by that time? Of course, we will survive, but we'll have to rebuild our civilization. But don't be afraid. If nothing depends on us, let's just enjoy every day of life. Be grateful and help each other. Supporting and caring for each other even during the volcanic winter is a guarantee that humanity will survive.
We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hot spot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called mushroom pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned. So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud ponds, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea. But sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be. And the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well, there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight.
It happened around 8.7 million years ago. All of a sudden, vast grasslands started to open. Clouds of volcanic gas and ash covered the sky. Flows of lava streamed down the hills and across the plains. Within minutes, black volcanic glass started to rain from above, wiping out animals, crushing plants. It didn't take long before the land caved in, opening giant pits filled with red-hot magma. It was the greatest eruption of the Yellowstone supervolcano. This giant, which is actually one of the largest active volcanic systems on the planet, wasn't named Supervolcano for nothing. Spreading deep underground and extending for hundreds of miles, supervolcanoes are complicated structures. Experts are still unsure what processes can trigger these fire-breathing monsters and lead to super eruptions. When it happens, more than 240 cubic miles of ash, molten rock, and hot gases get hurled up into the air. 4 super eruptions would be enough to fill the Grand Canyon to the brim. Volcanoes create mountains, but supervolcanoes wipe them off the face of the earth. They change climates and ecosystems. Thankfully, these disastrous events don't happen more often than every 50,000 years or so. Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground and burst through the Earth's surface. Usually, all this magma gets stuck, unable to break through the planet's crust. Large pools of pressurized bubbling magma gather at a depth of several miles. The pressure keeps growing since more and more magma is trying to get to the surface. And then, wham, bam, a super eruption goes off. All those millions of years ago, the first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust, leaving behind huge chambers. Those were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding after more and more magma arrived with time. The land over the volcanic system was inching upward, slowly, almost unnoticeably. A year before the super eruption, Yellowstone gave a warning. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression released gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle with soda after you've shaken it. Something like that was happening near the volcano. The pressure was released through the fractures when gases were bursting out from under the surface. Right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe, but the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurtled up into the air to a height of over 16 miles. Within several minutes, a pyroclastic flow rushed across the area at a phenomenal hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With the temperature of more than 1,300 degrees Fahrenheit, it was burning everything in its path. The volcano kept pumping ash for days on end. The air in that area heated up to 570 degrees Fahrenheit. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds after being inhaled and getting in the lungs. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. In the end, tiny particles of volcanic ash coated almost all the western part of North America. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. The monsoon seasons changed. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It covered more than 8,900 square miles of what's now southern Idaho and northern Nevada. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. There have been at least 3 other supereruptions in the history of the Yellowstone volcano. They happened 2.1 million, 1.3 million, and 64,000 years ago. They were 6,000, 700, and 2,500 times more powerful than the devastating eruption of Mount St. Helens in Washington state in 1980. The most recent supereruption was dubbed the Lava Creek Eruption. It formed the Yellowstone caldera after spewing out 240 cubic miles of rock, dust, and volcanic ash. These days, Yellowstone National Park is a mind-boggling collection of 10,000 mud pots, hot springs, geysers, and vents emitting volcanic gases. Heat-loving microorganisms live in most of them. They paint the park in its brilliant colors. The most famous geyser is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than others, erupting about 17 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach the height of 180 feet. Scientists have spent many years trying to figure out what's hiding under Yellowstone Park. They've discovered that surface water goes several miles down into the crust. It gets heated and boils, supplying the geysers. Around 7 miles below the surface, there's a reservoir of half-melted rock. That's the magma chamber, and it's more than 30 miles wide. An enormous plume of hot rock, which looks somewhat like a mushroom, feeds this chamber. It rises from the depth of 400 miles, traveling through the planet's upper mantle, a thick layer of mostly solid rock. Sometimes, this plume overheats the magma chamber. The land in that place lifts, and tiny earthquakes help some liquid escape to the surface. The pressure inside the chamber drops, and the ground lowers again. Since 2004, some parts of the Yellowstone caldera, which is a clever word for a volcanic crater, have been surging upward much faster than usual. The rate's been almost 3 inches per year. No uplift has been that quick since scientists started close observations in the 1970s. And still, experts are sure the supervolcano doesn't present any danger these days. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even if there's some volcanic activity, it's more likely to be a spurt of oozing molten rock, known as a lava flow. It does present some danger, but it's easily avoidable. Or it can be a hydrothermal explosion. Then, a large volume of superheated water trapped below the surface will rapidly turn from liquid into steam. This steam, along with boiling water, mud, and pieces of rock, will burst through the surface with great force. Then, the debris will litter the area of up to several miles in diameter.
Yellowstone is the internet's favorite doomsday volcano. Maybe you heard the prediction. One super eruption, then a continent dusted in ash and temperatures going down. A perfect disaster movie scenario. Yet, geologists worry about a different kind of volcano. One that won't explode only once. It could rip the ground open, flood the entire continent with lava, and make the air unbreathable. And we know this because it happened before. Right now, researchers think there might be around 20 supervolcanoes scattered across the planet. Short story, we fear those. Long story, a major supervolcanic eruption could collapse modern society as we know it. A normal volcano can cause a local disaster. It can wipe out a city and turn a region into a no-travel zone. When Mount St. Helens exploded in 1980, it was huge. The eruption blew the top off a mountain and flattened forests like knocking down dominoes. It showed the world just how scary volcanoes can be. But in geological terms, it's nowhere near what a supervolcano could do. Mount St. Helens threw out roughly a third of a cubic mile of ash, enough to make a football field pile about 150 miles high. For comparison, a supervolcano could bury the entire state of Texas 5 feet deep, and Texas stretches about 800 miles. Volcanoes like St. Helens are mountains that build up over time, layer after layer, like nature stacking spilled wax. They erupt, they cool, they erupt again, and you end up with a cone that looks cool in photos. A supervolcano is like a hidden pit. It resembles a giant underground tank of molten rock covered in a thick slab of crust. Imagine the magma chamber like a huge underground room, and the ground above it is the ceiling. During a super eruption, cracks rip open across that ground and magma forces its way up through them, like steam blasting out of a pressure cooker. Ash and gas roar high into the sky. It can start in multiple spots across a wide area, not one neat hole. The magma chamber underneath can empty so violently that the roof above it collapses, the land drops, and what's left is a massive bowl-shaped scar called a caldera. And Yellowstone is the prime example. About 631,000 years ago, Yellowstone had a massive eruption and it left behind a giant caldera about 30 by 45 miles across. Now it's a national park, but it's also basically a footprint, like a warning. If Yellowstone erupted again, the first super hot clouds of ash and gas could blast outward and burn everything nearby. Then the ash would spread, And ash is not like the fireplace dust. It hurts to breathe. It wrecks engines, and it can shut down flights and machines. Regular volcanoes mostly hit the area around them with lava. A super eruption turns the air itself into a real danger. Ash spreads far and jams the things we depend on. High up, sulfur can turn into a thin haze that will block some sunlight. That can cool things for a while and mess with growing seasons, even far from the eruption. And winds can spread that effect well beyond the US. However, geologists worry about something even worse. A kind of eruption that can keep going in waves and cover huge regions in lava. It's called a large igneous province. It's not one volcano. It's a whole stretch of crust that starts leaking lava through long cracks over and over for a long time. Instead of one giant explosion, it's more like Earth turning on a lava faucet that just keeps going. Imagine a crack in the ground hundreds of miles long. Out of that crack comes a sea of lava. But this isn't the sticky, slow stuff you see in Hawaii. This is hot, runny, fast-moving lava, and it doesn't stop. It spreads, floods low spots, stacks into layers, and then does it again. And that's what makes LIPs scarier than a supervolcano. They drag on. They can erupt in repeated pulses over hundreds of thousands to a few million years. We have scars to prove it right here in the US. About 17 million years ago, the Pacific Northwest ripped open and created the Columbia River basalt. Lava did not just coat the land, it drowned it. The total amount that erupted was around 42,000 cubic miles. That's enough to cover the whole US in lava about 58 feet deep. But how can Earth produce enough lava to bury a mountain range? It's because the planet is still churning inside. Imagine Earth like a pot of thick tomato soup sitting on a stove. Earth's core is the stove, and it's extremely hot. The soup is the mantle, a thick layer of rock that moves slowly. Now and then, a massive blob of superheated rock rises from deep in the mantle, possibly from the boundary above the core. Scientists call this a mantle plume. When it reaches the cooler crust, it spreads out, pushes upward, and when it breaks through, it does not build one neat mountain. It can open long cracks and feed eruptions in repeated bursts for a very long time. However, while lava burns everything in its way, it's not what wrecks the planet. The gas does. These eruptions release huge amounts of carbon dioxide and sulfur, and we can assume the consequences of that because it happened before, and not just once. About 252 million years ago, a massive LIP eruption began in what is now Siberia. It lines up with the worst extinction event in Earth's history, the Great Dying. Around 90% of species disappeared. Huge amounts of gas flooded the air and trapped heat. The ocean soaked up some of that gas and turned more acidic. Acid rain fell again and again. Life on Earth crashed. Scientists believe that in the last 500 million years, there have been 16 major extinctions like this, and that 15 of them line up closely with LIP timing. These geological formations changed Earth so many times, and scientists now wonder, what if Yellowstone and that massive lava flood in Oregon are actually a part of the same system? Look at Idaho from space, and you see a long, flat track across the state called the Snake River Plain. It points from the old lava flood region toward Yellowstone, like a trail. That path exists because Earth's surface moves. The outer layer is split into giant plates that slowly slide. Under Idaho and Yellowstone, a deep, hot zone keeps feeding eruptions. As the plate moves, the eruption zone shifts with it, leaving a long trail behind. That's why the rocks get older the farther you go from Yellowstone. It's the same heat source, just a moving target. And if you roll the plate's motion back far enough, that trail points closer to where the Columbia River basalts formed. That's why some geologists think the Northwest lava flood and Yellowstone could be connected parts of one long-lived system. Finally, if it's all part of one big apocalyptic system, is it time to pack the bags and flee to Mars? Will it happen again soon? Even if they share the same story, that does not mean the worst part is coming back soon. The lava flood chapter played out millions of years ago. Today, Yellowstone is simply where that deep heat shows up at the moment. And sure, it can erupt again, but the most likely eruption isn't some giant doomsday blast. It's a steam explosion, when super hot water flashes into steam and blows rock apart. Lava flows and smaller eruptions can happen too. The caldera-making nightmare is a rare one. If Yellowstone ever started building towards something big, it wouldn't be sneaky. You would see it coming. A lot more earthquakes than normal and the ground lifting faster than usual. The clearest right before signs would likely show up in the days or weeks before it. We cannot stop a planet-scale eruption. We can only watch for the warning signs and plan. But hopefully, if the planet decides to get rid of us, by the time it starts sending warnings, we'll already finish turning Mars into our new home.
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano.
For 70,000 years, Taftan volcano successfully convinced everyone it was extinct. But new satellite images show that its summit is rising, like something inside is stretching it, rolling it over, and cracking its neck after the world's longest nap. Scientists aren't too happy about it, so let's see if you have a reason to be worried too. Volcanoes can wake up when earthquakes shake them awake or storms mess with underground water. But scientists checked. There weren't any big earthquakes or heavy rains in southeastern Iran, where it sits. So it must be gas or magma pressure that's moving Taftan. It's like a sealed soda can heating up from the inside. Before you even hear a hiss, the pressure is building silently, waiting for a weakness. That's why Taftan's movement is such a big red flag. Pressure changes mean new internal activity. Plus, the source of pressure below its surface is at just around 1,600 to 2,070 feet deep. And that's not a lot for a volcano. When the source of pressure sits that close to daylight, it can set off small explosions from steam or gas, even if no lava ever touches the surface. This type of explosion, called phreatic, happens when water underground gets so hot so fast that it blows up like a giant pressure cooker. In Hollywood movies, volcanic eruptions always look like rivers of lava chasing people down the street. But steam-driven explosions are different, sneaky, and unpredictable. One minute everything looks calm, and the next minute rocks and superheated steam blast into the air like Earth sneezed with the power of a jet engine. For Taftan, this is exactly the scenario scientists are afraid of. You don't need flowing lava to cause destruction. A steam-driven explosion can launch boulders the size of cars and shoot ash clouds thousands of feet up. Even if you don't live anywhere near Iran, Taftan isn't just a local issue. Volcanoes breathe out gases that travel with the wind, and Taftan produces sulfur-heavy emissions when it's active. Sulfur dioxide doesn't just smell bad, but messes with air quality, irritates lungs, and reacts in the atmosphere to form particles that can dim sunlight and cool temperatures. That means neighboring countries might feel the effects even if they never see the volcano. And if a phreatic explosion blasts ash high enough, it could drift into international flight paths like volcanic confetti nobody asked for. Even smaller eruptions can have ripple effects. Remember that time a volcano in Iceland with a name I won't ever pronounce correctly blew up in 2010? It disrupted all the air travel across the Atlantic, and in our case, a modest ash plume drifting into major air corridors could ground flights across the Middle East, South Asia, and beyond. You know, gas emissions don't respect borders. They drift, mix, and settle wherever the wind decides to drop them. Alright, all this sounds pretty creepy, but with all the modern sensors, scientists should find out about an eruption in advance, right? Not really. As Taftan sits in a really remote region, setting up monitoring stations there is tricky, expensive, and frankly, was never a priority because everyone assumed the volcano was done for. So right now, satellites, not ground instruments, are doing most of the work. Satellites see the big picture, but instruments on the mountain add detail. And that's why it was so important for Taftan to be reclassified from extinct to dormant. Because dormant volcanoes need eyes on them 24/7. When a volcano is labeled extinct, countries don't invest in evacuation plans, hazard maps, or monitoring equipment. Changing Taftan's status forced everyone, from local officials to global scientists, to admit it can cause trouble. And that means preparing for ashfall, gas emissions, sudden eruptions, and the long-term questions. Questions like, what if this awakening isn't temporary? What if this is the beginning of a whole new activity cycle? Long-term, Taftan might settle down again, or it might be entering a period of renewed activity. Volcanoes don't run on human timelines. A short-term phase for a volcano could be days or years, and the uplifting summit might mean there's deeper magma movement, not just a surface burp. It has gone up by about 3.5 inches over 10 months between July 2023 and May 2024. And a mountain rising is like Earth inhaling. And if Earth inhales too deeply, it eventually exhales. And in volcanic terms, that exhale is nothing good. Right now, Taftan is breathing in, and nobody knows when it plans to breathe out. This already sounds like too much drama, but there's more where it came from. Some of the biggest, angriest supervolcanoes on Earth are starting to wake up. When one of these monsters erupts, the whole planet feels it, even people living thousands of miles away. Scientists worry because a super eruption could move faster than our ability to prepare food, evacuate cities, or deal with the chaos afterward. That's what makes supervolcanoes so scary. Not just the explosion, but how little time we might have to react. If you live near Naples, you already know at least one supervolcano and how it acts. Streets crack, steam leaks from the earth, the harbor fills with sediment, and swarms of small earthquakes rattle windows like underground thunder. All of that comes from Campi Flegrei, a massive supervolcano caldera that last erupted in 1538. For years, scientists read these signals as classic warnings of magma rising. But two recent studies, one in 2023 and another in 2025, completely changed how we understand what's really going on. And surprisingly, they brought a bit of hope with the danger. In 2023, studies zoomed in on carbon dioxide, a gas volcanoes pump out when magma starts acting up. At Campi Flegrei, CO2 levels jumped after 2005 to about 4,000 to 5,000 tons a day, which sounds like magma rising fast. But when scientists checked other gases like nitrogen and helium, the chemistry didn't fit that idea at all. It turned out that the extra CO2 came not from rising magma, but from super hot fluids underground, cooking the surrounding rocks and releasing gas on their own. In the 2025 study, lab experiments showed that the shaking comes mainly from a sealed underground water and steam reservoir. When that natural lid traps pressure, it eventually cracks and releases steam and sets off sudden quakes that people feel at the surface. That idea also explains something that always confused scientists. The earthquakes usually start close to the surface and then move deeper, which is the opposite of what rising magma would do. After the strongest shaking, the ground often sinks a little, like a balloon slowly deflating after you let some air out. None of this means Campi Flegrei is suddenly safe though. Magma still sits deep underground, and steam-driven explosions can still blast out rocks, ash, and scorching gas without any lava warning you first. What's really changed is how scientists think about the danger. Just watching and waiting isn't enough anymore. If humanity only had 12 months of warning before a supervolcano eruption, we'd struggle badly. Stockpiling food, relocating people, keeping supply chains alive. It would all feel almost impossible. But don't freak out yet, because supervolcano eruptions are extremely rare. The last one happened about 26,500 years ago in New Zealand. On average, scientists think a super eruption happens roughly once every 100,000 years, but Earth doesn't follow neat schedules like a calendar. Sometimes these eruptions cluster closer together, and then the planet stays quiet for a long time. Two massive super eruptions shook the planet within the last 100,000 years. About 74,000 years ago, Indonesia's Toba volcano blew up with such force that it blasted ash across Asia, lowered the temperatures around the world, and may have pushed early humans to the brink of extinction. Then, around 26,500 years ago, New Zealand's Toba volcano unleashed an eruption, covering huge areas in ash and reshaping the landscape we see today. There's always a chance another super eruption could arrive earlier than we expect. That uncertainty is what keeps scientists awake at night.